are going to explain what differentiation means and the main techniques we use to differentiate functions. Differentiation is the process of finding how fast a function is changing at any point. It helps us find the gradient or slope of a curve at a specific x value. The result is called the derivative, which shows the rate of change of the function. So for question 2a, we're going to find the derivative of this equation, which is y equals 3 times ln of 4x multiplied by sine square of 7x. So this function is a product of two separate parts. We apply the product rule, which tells you that the derivative of u times v is u prime v plus u v prime, or you could just use this one. Okay? So we let u equals to ln of 4x and v equals to sine square of 7x. And we differentiate each part step by step. First, we differentiate u. We recall that ln of 4x can be expanded using log rules, which is ln of ab equals to ln of a plus ln of b. Now, ln 4 is a constant and the derivative of a constant is 0. The derivative of ln x is 1 over 0. Next, we differentiate v, which is sine square of 7x. So first, we bring down the power. The derivative of sine square is 2 times sine 7x. Then we multiply by the derivative of the inner function. The derivative of sine 7x is 7 times cosine 7x. Altogether, we get this 14 times sine 7x times cosine 7x. Now we substitute it into the product rule formulas. U prime v plus u v prime becomes this. But I use v. You just substitute this and then you will get this. And since we have a constant 3 in front of the whole expression, we multiply the entire result by 3. So the final derivative is dy over dx equals to 3 times the quantity sine square of 7x over x plus 14 ln 4x sine 7x cosine 7x. That completes our differentiation using both the product rule and chain rule.
The question 2b, they ask you to find the dy dx of this equation. So we know that this equation is a fraction. So if it's a fraction, we need to use a quotient rule. So for the quotient rule, the formula is v du minus u dv over v squared. So for the numerator is u and for the denominator is v. So first we need to substitute the u and v inside the formula. So v, which is x minus 2 times the differentiation of v, which is 6e to x minus 3e to x, and the differentiation of v, which is 1 over v squared, which is x minus 2 squared. So after that we need to multiply it, and for this we can get this, and for the 3 to x times 1 we get 3e to x, and the denominator is not changed. So as we guys can see that 6e to x and 3e to x share the same e to x, so we can factorize it. So we can factorize it by 3 to ex times 2, which is if we multiply it, we can get 6e to x, and put a bracket x minus 2, which is this one, and minus 1, which is if we multiply it, we get minus 3e to x, which is same as here. So the bottom is not going to change. So we can simplify it as this one, we multiply, and we get 3e to x, bracket to x minus 4 minus 1, and we simplify it, and we get the answer, which is 3e to x, bracket to x minus 5 over x minus 2 squared. So this is the final answer.
Next next question, I'll be explaining a calculus equation involving an implicit differentiation of given equation. So let's go through it step by step together. So this is our original equation given, and as we can see, we are dealing with an implicit differentiation because y is not isolated. So that's why we will need to use implicit differentiation to find dy over dx. So step first, we need to differentiate both sides of the equation. So first we need to look at the left hand side. As we can see, we have three terms on the left side. This, and this. Okay, so on the right hand side we have exponential function. So for the first step we will differentiate for the first term, which is y times 3x plus 1. So we will differentiate the first term. We will put dy over dx in front and at the end. So and then we will cut the answer for the first term. Like this. So and for the second term, we will use the chain rule equation. So we need to apply chain rule on this term, and by using the chain rule, we will cut the answer like this. And for the negative 5, which is the third term on the left side, when we differentiate it, it will become 0 after differentiation. Okay, so next we will differentiate on the right hand side, which is the exponential equation. And so this is also chain rule, which is same like the second term, which is the long one. And after we differentiate it, we will cut the answer like this. Okay, after we differentiate all of the terms, so we need to substitute everything into one equation. So after we substitute it, we group all terms with dy dx on one side and the rest on the other side. So the other side, which is with dy dx on left side, and the others we will put on the right side. So next we will factor out dy dx from left hand side, which is divided. Okay, and then lastly we divide both sides to get the final expression for dy dx. So now we will be moving to our last question, which asks us to search for the linear approximation for the equation 3 multiplied with bracket 7.92 squared plus 2 over root q 7.92. So our general equation for linear approximation is f theta x equals to fx plus f prime x multiplied by theta x minus x. So first of all, we need to find the x naught. So our theta x is 7.92. So we need to find the closest to 7.92. So it's 8, the closest. So now we're going to find the difference between the theta x and the x naught. So we are going to take theta x and minus it with x. So we will get negative 0.08. We are going to take 3x squared plus 2 over root qx. So now we're going to substitute the x with 8. So now it's 3 multiplied by 8 squared plus 2 over root cube 8. And now we will get the answer 193. Now we will search for f prime, which is we differentiate our original equation. So for our first derivative from our original equation is 6x plus negative 2 over 3 multiplied with x power negative 4 over 3. So we substitute the x with 8 once again. Now 6 multiplied by 8 is 48, and plus negative 2 over 3 multiplied by 8 with the power of negative 4 over 3 is negative 1 over 24. So now we will get our answer 1151 over 24. So now we take all the answers that we just got and put it in our general equation. So for our theta x, it's 7.92, so we substitute there. And f equals to f8, so we will put 193 because that's the answer. And for the f prime 8, it's 1157 over 24. And we will be going to put the negative 0.08 multiplied with f prime. So now we get 193 plus 1151 over 24 multiplied with negative 0.08. And we will get the answer 189.1633.